All right, hello everyone. Last time we talked about freshwater ecosystems. So this time we are going to pivot a little bit and talk about saltwater or marine ecosystems and resources. So obviously oceans make up a majority of the surface of the planet. About 71% of the Earth's surface is currently covered by an ocean. So this is a ton of real estate taken up. This means that oceans have a huge influence on um, the atmosphere, climate, water cycle, and they encompass a ton of the biosphere. So a lot of important ecosystems are included in that 71% of the Earth's surface. And obviously, oceans aren't stagnant. Oceans are driven by currents, and currents are water along the surface. It's the horizontal movement of water. So currents are driven by lots of different things, mostly differences in water density, temperature, gravity, wind. All of these things drive the ocean's currents. And we have many, many different important currents throughout the world. You can see many of them depicted here. Let me get my laser pointer. There we go. And these currents can be very rapid, very powerful, and have big influences on the climate in different areas of the world. These currents can also carry things like nutrients, which can be positive or negative for different areas of the ocean. They can carry other types of pollution like plastic, which we'll get into a little bit later in our lecture today. And we call this circulation of worldwide currents thermohaline circulation. The thermo part comes from the different temperatures that we experience. So if you see thermo, think temperature, heat. And the haline part comes from the distribution of salt, because not all water in the ocean has the same concentration in the salt. The saltier water is, the denser it tends to be. So that means the heavier it is, the lower it is in the ocean. So we tend to have warmer, lower salinity water up near the top, near the surface. That tends to be the water that's moving um, quickest. And then we have deeper, denser, saltier, colder water um, further down. Because of this system of currents, this thermohaline circulation, we have water moving all over the world in these different currents. One of the main ones that we'll talk about here, we call the Gulf Stream. The Gulf Stream is a very important current right here that takes water from the Gulf of Mexico right around this equator region. So this water tends to be very warm, and it pulls that water up all the way towards Europe. So this water from the Gulf Stream is very warm, and it actually helps moderate the climate of all of these areas in Europe. So you might have looked at a map before, seen um, Great Britain and Ireland all the way up here. About if you make a line across the map here, they're at the same latitude as regions in central Canada that are extremely cold, have very harsh climates, has a very harsh climate throughout the year. But places like Great Britain have a relatively moderate climate. And this is primarily because of this warm water system being pulled up via the Gulf Stream. So this warm water helps to moderate the entire climate of Europe. It's a very important system. Now, scientists are becoming increasingly concerned that due to global climate change, we are seeing a lot of ice melting from Greenland, and that when that ice melts, all of that cold water is then just dumped into the ocean up in this region. And scientists are concerned that with this cold, fresh water being increasingly um, increasingly entering into the ocean, this is going to disrupt some of the important currents um, in the world, especially this Gulf Stream current that again carries water from the Gulf of Mexico all the way towards Europe. So if we have cold, fresh water entering here, that's going to disrupt things a little bit. Water is going to lose heat. Um, that means it's going to become a little bit more dense, sink down just a little bit. So if we disrupt this current, the entire climate of Europe is going to be altered along with that, because again, these currents are very important for moderating climate all over the place. So this is a serious issue, one of the serious issues that scientists are concerned with when it comes to things like global warming. Okay, so just like last time, where we talked a little bit about different types of freshwater ecosystems, so we're going to now just touch on some important marine and coastal ecosystems. And these are very diverse ecosystems. Certain areas of the ocean are support some of the highest levels of biodiversity that we see anywhere in the world. Just like with lakes, we divide the ocean into separate layers. So the top layer of the ocean near the surface we call the photic zone. And you can see that prefix photo, you should think light. The photic zone is the area where sun can penetrate. So the photic zone is where most of the photosynthesis is going to occur in the ocean. That's where those photosynthetic organisms are going to be. This is where a lot of feeding is going to take place in this photic zone, because a lot of fish and other organisms depend on those photosynthetic microorganisms to survive. So this is where most of the ocean's primary productivity is going to occur, in this photic zone where solar energy can reach. Now, underneath that photic zone, we have the pelagic zone. And the pelagic zone is the area between photic zone and the ocean floor. And just like with lakes, we call the ocean floor the benthic zone, that area all the way down below. If we come closer to the shore, we have a region that we call the intertidal zone. The intertidal zone is a very unique ecosystem between the areas where low tide and where we have low tide and high tide. Because as the tides change throughout the day, let's say this is an area along the beach here. During high tide, this area may be completely submerged in water. But by the time we get to low tide, the water is going to recede a bit in this diagram to about here. So that means this entire region here is then open to the air. So organisms living here need to be able to deal with a lot of change. And this results in very, very diverse ecosystems, because these organisms are exposed to the sun for part of the day and covered by water for the rest of the day. So these are extremely diverse ecosystems. You can see this area here filled with what we call tide pools, these little areas where you can see the tides have receded. Certain areas, though, are still filled with water. These are called tide pools. And if you ever get a chance, I highly suggest getting out to an area like this, exploring a little bit, looking through these tide pools, because this is a highly diverse ecosystem, a ton of really cool organisms living in these tide pools, very diverse. So as we talked about in our last lecture, rivers always end up leading to either large lakes or the ocean. The intermediate zone between where we have the ocean and a freshwater river, we call an estuary. And estuaries are, again, bodies of water that are that intermediate zone. So they are a mix between fresh water and salt water. They act as a nice transition for organisms that might be able to survive in either fresh or salt water. This is a nice little transition point where they can kind of get acclimated to um, those high salinity conditions. We've also seen some kelp forests before when we were talking about invasive species. Kelp forests are also extremely diverse ecosystems. Um, they behave as underwater forests. You can see these huge branches of kelp that can be hundreds of meters long, extend up from the surface, or from the floor of the ocean to the water surface. So these are actually huge um, huge pieces of large brown algae. This provides a ton of shelter, places to hide, places to live for many organisms, provides a source of food. So these are really important ecosystems for supporting a lot of life along the coast and oceans. And finally, we come to coral reefs. And you all know what coral reefs are. You've all seen plenty of coral reefs um, in your life, maybe not in person, but movies, TV. Coral reefs are some of the most biodiverse regions on our planet. So just like rainforests, coral reefs are extremely important to support some of the most or the highest number of organisms that we see on the planet. And coral reefs are a mass of calcium carbonate that actually come from a lot of tiny animals that we call coral. So this right here is not just one organism. This is a accumulation of calcium carbonate that is secreted by tiny little organisms. If we were to look a lot more closely at this image, you'd see tiny little holes in this coral, and each hole can support one tiny little animal that lives in this community we call coral. And there are three different regions that we find coral reefs. We can find extensions of a shoreline, so just just on the outside of a shoreline, we can find coral reefs. We also have what we call barrier islands that are sort of a mass of coral that is parallel to a shoreline. And then we could also have a ring around a submerged island that we call a coral atoll. So as I said, coral are tiny little organisms, and they're actually related to jellyfish. Um, so they have small tentacles that they can capture tiny food particles with. And corals all have a important symbiotic relationship with algae called zooxanthellae. And zooxanthellae are photosynthetic organisms, so they can produce food um, using sunlight. So that's why we need you don't find coral deep in the ocean. We need sunlight in order for a coral reef because of this important relationship that all coral have with zooxanthellae. And I know it's a big, scary word, but zooxanthellae are simply algae that help out coral. And I have a little video here that um, should go a little bit more into this. Maybe, if I can get it started, we'll see.
join with other colonies and become reefs that can grow to hundreds of miles long. The largest coral reef is Australia's Great Barrier Reef, which began growing about 20,000 years ago. Coral reefs are some of the most diverse ecosystems on Earth, though they cover less than 1% of the ocean floor. Coral reefs are home to 25% of all marine creatures. It's been estimated that up to 2 million species inhabit coral reefs, rivaling the biodiversity of the rainforest. The reefs provide rich habitat that helps protect young fish as they grow. Coral are translucent. Coral reefs get their rainbow colors from algae or zooxanthellae that live in their tissue. The corals use their tentacles to capture some food. Most of their food comes from the algae they house. When coral becomes stressed by pollution or other factors, they evict their algae. Coral bleaching results revealing coral's white skeletons. Coral provide a window to the past. As coral grow, their limestone skeletons form layers similar to tree rings that vary in composition and thickness based on ocean conditions at the time. With some coral reefs growing for thousands or even millions of years, scientists can study these layers to reveal what the Earth's climate may have been like in the ancient past. Unfortunately, climate change is putting corals' future in danger, along with the millions of species that inhabit the reefs and the half-billion people that rely on reef fish for food. Warming waters result in prolonged coral bleaching that kill coral reefs or leave them vulnerable to other threats. Without significant action on climate change, our oceans could lose many of their colorful reefs by the end of the century.
All right. So I am sorry if the audio for that video did not work. And fortunately, I can't really check until after this recording. So if you were unable to see audio or hear audio along with my lecture here, please, I encourage you to go and watch those videos. I put the link for all of these PowerPoints on Moodle for you, so you should have access to any video that I have in this presentation. So please make sure, if you couldn't hear that audio, you go watch each of these videos after this lecture presentation, because there's some really useful information included in all of those. Okay, so as we saw in that video, many coral reefs have fallen victim to what we call coral bleaching. And coral bleaching is when corals expel those zooxanthellae, those algae that they have that important relationship with. And this actually causes coral to lose their color because the color in coral comes from those zooxanthellae. So coral themselves are actually colorless or white. So when they do not have the algae anymore, they look like this. And that relationship with the algae is extremely important for the survival of coral. Zooxanthellae provide coral with a lot of the food that they need to survive. So when they expel coral due to things like rising water temperatures, elevated pH, other forms of pollution, fortunately, this in many cases results in the death of the coral. And this is happening all over the world right now. So this is really another important reason why dealing with global warming is extremely important. So I talked a tiny bit about pollution. Most of the pollution, or specifically marine pollution, but most water pollution in general, prior to the 1970s was what we call point source pollution. And point source pollution is any pollution that has a single identifiable source. So this is kind of what you might picture when you think of corporations polluting the ocean. We have the huge pipe here. It's very obvious where the pollution is coming from in this image. So this is point source pollution. And this was very common until the early 1970s in the US, where we passed the Clean Water Act. And the Clean Water Act made cities and corporations no longer able to pollute in this way, to just put pipes facing the ocean and kind of think of it as out of sight, out of mind. So since the 70s, we've been really dealing with all of these point source pollution sources and eradicating them as much as we can. So nowadays, most marine pollution that we have is what we call non-point source. And as opposed to point source pollution, where we can find a single identifiable source, non-point source pollution arises from countless small sources of pollution that eventually make their way into the ocean. And the primary culprit of non-point source pollution is plastics. And plastic debris, I'm sure you all know, it's very detrimental for marine life. It can cause them to become entangled. Many organisms ingest plastic because they don't understand what it is. It's just a colorful object. A lot of plastic, as it breaks down, can actually look like the food source for many of these organisms. Um, so plastic debris, bottles, bags, fishing line, um, many other sources can be extremely, extremely detrimental for many organisms. And you might have seen images like this for in the Pacific Ocean, where we have this huge, huge mass of floating plastic and debris. And this is what we call the Great Pacific Garbage Patch, or Trash Island, as some people call it. And this is a result of plastic in the oceans being carried by our ocean currents into what we call a gyre. And in many different areas of the world, we have areas where these gyres, where areas where we have ocean currents converging. So many different currents converge in one single area, acts as kind of a meeting place for these currents. Unfortunately, anything carried along with the water comes as well. So we have regions throughout the ocean where we have these huge masses of plastic. And in specific, in the North Pacific Gyre, we have this giant, giant area of garbage that is where plastic pieces outnumber organisms from 6 to 1. So we can just see the surface of the ocean here. If we were to go under, there would be billions and billions of shards of floating plastic as well. So this is a serious, serious issue. Obviously, any organisms living in this area are dealing with tons of tiny little plastic pieces that can be extremely detrimental to their health. And I believe I have another video here. So again, I'm sorry if the audio wasn't working, you can go ahead and try to skip ahead a minute or two and watch this video on your own time. It'll talk a little bit about the problems that we are seeing today with plastic in the oceans. I do warn you, if you are a bit squeamish, this video does show some of the researchers direct on the front line investigating issues with birds consuming plastic. So yeah, just a little warning before we get into it here.
Plastic is wonderful because it's durable, and plastic is terrible because it is durable. every piece of plastic ever made is still on the planet in some form or another. Plastic production globally this year is expected to be more than 300 million tonnes, half of which we'll use just once and then throw away. By 2050, when the population explodes to almost 10 billion people, it's expected that plastic production will triple. The problem with that is that today only a fraction of the plastic that we produce is recycled. The rest ends up in our environment, and it's coating our lands and our oceans like a disease. Garbage thrown away in the United States make its way to Antarctica. Plastic in our coastal waters is pulled to the center of massive wind-driven, churning circular gyres. There are many other ocean currents also diverting the trash all around the surface of the ocean. In reality, it's just one ocean with no boundaries. Lord Howe Island is a World Heritage Site and home to migratory seabirds like the shearwaters. Seabirds are incredibly helpful because they act like an army of scientists. They travel thousands of miles across the ocean. They pick up plastic off the surface of the ocean. They bring it back to their rookeries where they feed it to their chicks. And that provides an incredible amount of scientific data in terms of where the plastic comes from, its distribution, and how it breaks up on the ocean surface. Dr. Jennifer Lavers, she's devoted her life to studying the plight of seabirds. Shearwaters are incredible birds. They migrate thousands of miles, stopping only here to breed.
Yeah, the stomach is very, very full. And if we look here, there's some very dark pieces, some very light white pieces. And if you see, as I push on this, it's absolutely rigid, completely full of plastic all the way up.
Look at that.
Absolutely no doubt this bird died as a result of that plastic. That is literally a gut full of plastic. It's quite alarming, isn't it?
It's awful.
Range of plastic types and colors. We've got everything from the blues and the reds.
His stomach's just filled with it. Big pieces too.
Big sharp
Heavy.
pieces.
Oh wow, look at the size of that big flat piece.
That is an enormous piece of plastic.
Unbelievable. The size of that. Jen, I counted 234 pieces of plastic out of that one bird. Is that a record?
Not even close, unfortunately. So for the species, the record is 276 pieces of plastic inside of one 90-day-old chicken. And that plastic, when we weighed it out, accounted for 15% of that bird's body mass. That's a pretty scary statistic. If we translate that into human terms, it gets even worse. That would be equivalent to you and I having somewhere around 6 or 8 kilos of plastic inside of your stomach. It's equivalent to about 12 pizzas worth of food inside of your stomach. Quite a bit of plastic for just one little bird. accounts for trying to do the right thing. There's a lot of squid beaks in here, and this purple colour is evidence of the squidding. It's just a shame that every now and then they got it wrong in a bad way. Really is quite an overwhelming thing. I do have some pretty rough days, have to go home and wrap my mind around where do we go from here.
As a Pacific Islander, I know that the ocean is in deep trouble. The very authoritative prediction shows that by the year 2050, there will be as much plastic as there is fish in the ocean by weight. Every country uses plastic. We need to start rationalizing that. We need to think about reuse of plastic, single-use plastics. Got to be on this way out. But plastic shopping bags are a good example of that. Your family does not need to use it. Take a cloth bag with you when you go shopping. Put your shopping in there. There's an equivalent of a large garbage truck every minute of every day backing up to the ocean and just dumping plastic into it. We really have to look at ourselves and say, do we deserve this beautiful ocean?
All right. So again, I know some of that video is a little bit hard to watch, but it's really powerful. Really powerful. Some imagery there to get you thinking about how much of an issue this plastic really is entering our oceans. And again, I'm sorry if the audio in this recording isn't functioning properly. I'm learning as we go here as well, just like all of you. So please bear with me a little bit. But these PowerPoints are available to you on Moodle on their own as well. So please, if the audio is not syncing up here, please make sure on your own time you go and watch these videos as well. So the only way for us to deal with this plastic problem at this point is to prevent any further entry of plastic into the ocean. And for us to do that, we really need to take a look at our lifestyle, take a look at how we are disposing of our plastic, how much plastic we're actually using, and remedy that situation. So single-use plastics, as the video just said, need to be eliminated. Things like single-use plastic bottles, plastic bags, there's no reason for us to need to use those at this point. And one thing that really helped with the input of plastic into our oceans is the passage of the Marine Debris Research Prevention and Reduction Act. So this act here helped to ban the use of plastic microbeads. So in the past, we've used plastic as you might have bought a body wash or a toothpaste that had tiny little beads in it that were supposed to help either clean your teeth better or help provide a little bit of texture to help exfoliate your skin. The problem, though, is that those beads were composed of plastic. Plastic doesn't break down. So these tiny little microbeads of plastic, just like all of our other sources, and even more so because with things like toothpaste, things like body washes, we're just washing that plastic directly down the drain. So using these products means you're just putting excess plastic directly into the ocean, basically. And these microbeads of plastic don't break down once they reach the ocean. That means organisms are taking them in, consuming them. So the banning of these plastic microbeads has helped stem some of the problem, but still single-use plastic, our use of it needs to be reduced as much as we possibly can. All right, so pivoting away from plastic pollution, We also, just like with freshwater places on Earth, have issues with nutrient pollution. And in the same way as the eutrophication that we saw in freshwater systems, we can have the same exact thing occur in the ocean. So excessive nutrients can result in population explosions of marine algae. When these algae die off, the decomposers on the floor of the ocean um, become extremely active. They take up, and because they're so active, they remove the oxygen from the surrounding water, creating dead zones. Just like the eutrophication in freshwater, we have issues with eutrophication in marine ecosystems as well. In some cases, these dead zones, these marine algae can actually release toxins that are harmful to the organisms living in these places. So depending on where you live, there are certain places where beaches can actually be completely closed down because of these harmful algal blooms. And some of these algae, as a result, produce these reddish pigments that we call red tides. So if you look down from an overhead map, you can see vast regions in these areas where we have huge algal blooms. Eventually, those lead to dead zones, just like in those freshwater areas. So this is too many nutrients can lead to a lot of problems, not only in freshwater systems, but in the ocean as well. So in addition to pollution, we also have a huge issue in marine ecosystems because of overfishing. And of all the human impacts on the ocean, overfishing may be the most pressing at this time. More than half of all marine fish populations that we have on the world are what we call fully exploited. And fully exploited populations means that any additional harvesting of those populations would be unsustainable. So more than half of places in the world where we would normally fish, we can no longer do so because those populations have been so overfished that it's unsustainable to do anymore. And obviously, since the 1950s, our technology has vastly improved for fishing. So you'd think that as technology is improving, we would be able to catch more and more fish, but this isn't the case. So you can see here in this red color, we're starting in 1950. This graph here goes all the way through 2012. And as we go higher up on the y-axis, it means more and more fish are being caught. So you could see a pretty big increase from the 50s to about the 70s into the 80s. But by the 90s, you could see that this graph has plateaued a bit. So even though it's been 30 years since 1990, we've improved technology. We now have really advanced GPS units, sonar that helps us, that can help us find the fish, catch them more easily. You could see we've not actually been harvesting more fish since the 90s. And this is primarily because of industrialized fishing. So just like in agriculture, we've really ramped up our fishing strategies. We now use huge boats that can put out nets that are kilometers long, up to like kilometers wide. So we're just putting out huge nets. Anything that gets into that net is caught. And we've been doing this since the 18th century, but technological advances in the 20th century, those massive ships have allowed commercial fishing to skyrocket. And this is the primary cause of fishery collapses that we're now seeing today. One of the major downsides of industrialized fishing is what we call bycatch. And bycatch is when fishing vessels accidentally capture animals that they didn't mean to catch. Up to 17% of all commercially harvested fish were captured unintentionally. So this means if a vessel is going out attempting to capture tuna, um, a portion of what they catch is not going to be tuna. This is what we call bycatch. And there's a few methods of industrial fishing that are much worse when it comes to bycatch. I encourage you, if you're interested in this, to read through the chapter in your book. It goes into many of these methods in detail, but fortunately, we just don't have the time to cover this in as much detail as I'd like. But things like purse seining, drift netting, where again, drift netting is when we just put out a huge net behind a large fishing vessel. That fishing vessel drives along in the ocean, and anything that gets captured in the net, they pull up. Methods like this are extremely detrimental for things like dolphins, sea turtles, seals, who can unintentionally end up captured in the net as well. And depending on if the net is held underwater for too long, things like dolphins, seals can end up drowning, or if they are pulled up onto the ship along with all the other fish, they can end up dying of exposure on the surface. One more video here that will talk a little bit more about this.
There are currently 7 billion people living on 30% of its surface, and all of them are dependent on the remaining 70%, the ocean. The ocean is the largest source of food in the world. Fish is the main daily source of protein for 1.2 billion people. But fishes are more and more frequently returning home with empty nets. Let's turn the clock back a little. Some scientists say that in the last 60 years, stocks of large fish have fallen by 90%. They're warning that we are facing the collapse of all types of fish species in less than 50 years. The reason for this? Overfishing. Longline fishing vessels deploy 1.4 billion hooks a year. 1.4 billion hooks, each with a slice of fish hanging from them as bait. There are trawling vessels that cast nets with an opening of up to 23,000 meters squared, the size of 4 football pitches, and big enough to hold 13 jumbo jets, or more commonly, more than 500 tons of fish. Amongst these 500 tons of fish, there is a lot of bycatch. Bycatch is marine creatures incidentally caught, often at large quantity. Typically, shrimp trawlers throw 80 to 90% of the marine creatures caught back overboard. This means that for 1 kilo of shrimp, up to 9 kilos of other marine wildlife is caught and wasted. To relieve the strain on wild fish, 47% of our seafood demand is farmed fish. But marine aquaculture is more of a nail in a coffin than a lifeline. Many of the farmed fish are carnivorous. That is, they eat other, smaller fish. 5 kilos of captured wild fish are needed to produce 1 kilo of farm-reared salmon. Aquaculture just converts low-value small fish into higher-value bigger ones. It does not create more fish. The majority of European fish stocks are overfished. Historically, EU fisheries ministers have set fishing limits exceeding scientific advice. In 2008, fishing limits were defined for the highly prized bluefin tuna. Scientists recommended a fishing limit of 10,000 tons to rebuild the increasingly depleted population. However, the EU and other fishing nations decided on a fishing limit of 29,500 tons. 3 times what scientists had suggested. Then, despite this already inflated limit, 61,000 tons of bluefin tuna were caught. That is 6 times more than the recommended limit. Billions of euro in public subsidies are fueling this overfishing. If this continues, soon there will be no fish left. How do we end overfishing? Your politicians have the responsibility for making the decisions in Brussels that will end overfishing. Citizens have responsibility of encouraging and supporting their politicians to make those decisions.
Okay, so that video was specific to the European Union, but the same issue is happening all over the world. We have the same exact problems right now in the United States. In places like Asia and Australia, we're dealing with the same issues of commercially overfishing, despite scientists warning us that this is an unsustainable practice. So back to talking a little bit about bycatch. Here we have a graph depicting on the x-axis the year, so this is going from about 1960s to about 2010 or so. And on the y-axis, we have the number of dolphins in the thousands caught as a result of bycatch. So you can see throughout the 60s and 70s, we caught a massive amount of dolphins due to bycatch. And this was such an issue in the 60s and early 70s that the Marine Mammal Protection Act was instated. And this put a lot of new restrictions on how fisheries were operated to try to avoid catching dolphins, other marine mammals, as much as possible. So since the Marine Mammal Protection Act was instated in the early 1970s, you could see we've drastically reduced the amount of dolphins that we have caught. This has been, we have also made the public more aware of this issue by you might have seen some tuna labeled as dolphin safe. So eco-labeling brings this problem to light a little bit more, makes consumers a little bit more aware of this issue. So I encourage you to look for this dolphin safe labeling if you're buying things like canned tuna, canned salmon, things that bycatch might be an issue with. So you can see we've had a drastic decrease in the amount of dolphins that we've caught since the 1960s and 70s due to bycatch. Unfortunately, though, this has not resulted in a recovery of dolphin populations. So here, similarly, we have dolphin populations on the y-axis, year on the x-axis. So you can see in the 60s and 70s when we had those severe issues with bycatch, you can see huge declines in dolphin populations. Now, although we've gotten a lot better with this, dolphin populations have yet to recover. So obviously we need to do a little bit more. We need to change policies, really try to target this issue in different, more educated ways. And part of what fishery managers do to alleviate issues with overfishing is using surveys, fish population studies to help monitor changes in fish populations and look at the techniques they're using and how they are affecting overall fish populations. And their goal here is to, just like we talked about in the timber industry, to establish a maximum sustainable yield. And this means that they are harvesting as much as they can to reap that economic benefit, but they are not harvesting enough to for those harvests to be detrimental to the ecosystem and fish populations. Despite these efforts, though, fish stocks have continued to crash, suggesting we need to make some further changes. Specifically, scientists recommend using ecosystem-based management systems. And this means treating these areas where we're harvesting fish as ecosystems and thinking of them as functional, healthy ecosystems that we need to protect. And we can protect these areas in a few different ways. One of the ways we can is to designate areas as marine protected areas, or MPAs. And marine protected areas do restrict some human activities, so you can't do things like drill for oil or do any sort of mining in these marine protected areas, but they do allow fishing and some other activities to continue. So about 3% of ocean waters have this designation. Anything in purple here is designated as a marine protected area. So activities are regulated in these areas, but not prohibited. A step beyond this is to designate an area as a marine reserve. And a marine reserve is an area of the ocean where fishing is completely prohibited. So in a marine reserve, fish and other organisms are allowed to survive and reproduce as they normally would in a natural setting. So commercial and recreational fishers aren't crazy about these areas, obviously, because they're not allowed to fish here. But scientists argue that these areas are extremely important for replenishing our fish populations. These areas can serve as production factories, if you will, for fish in surrounding areas. Just like with our terrestrial preserves, though, there is a debate on what size that these should be. If we have a very small reserve, these animals may be dispersing too easily, so they might be leaving the reserve. If we have a medium reserve, these areas may, so just like the small reserve, we may have some fish leaving, but this can actually be a good thing, because if fish are leaving, those fish can go on to repopulate other areas outside of the reserve. And this is kind of the whole idea behind these reserves. We want to have a thriving fish population within, and we want some of those fish to leave the reserve to help repopulate other areas. When we have a very large reserve, this is very protective for the fish within, but doesn't allow for much spillover. So if we have a large reserve, we might have a ton of fish within, but large reserves don't do as good of a job as helping to replenish fish populations outside of reserves. So there's kind of a Goldilocks scenario here where medium marine reserves tend to be ideal, because we have thriving fish populations within the reserve, and they're small enough where fish will disperse, hopefully leading to booming fish populations on the outside. I have one final video here that talks a little bit more about these reserves and protected areas.
Between humanity and the open water, marine protected areas enable the ocean to rejuvenate without human interference. They serve as replenishment zones for fisheries, provide safe harbors for entire ecosystems.
It's bringing tourism into the area. Fish is worth more a mile than it is down here. Maybe having a marine reserve and building a tourism industry is one way that we can create a future. Guardando ese equilibrio es perfectamente posible crear parques marinos.
Stewardship of our ocean is not a one-person event. It's a universal requirement all across this planet.
All right, so that is it for marine ecosystems and resources. So make sure you keep an eye out for a quiz that I will post on both freshwater and marine ecosystems. So I'm going to combine both of these last lectures into one quiz for us. And then we will move on now to talking about climate change. So I do have a documentary we will watch that goes along with climate change. This time, I will make sure that you all have access to it on your own time, so you're not required to come and watch it synchronously with me. So keep an eye out for that. I will post an update letting you know when this quiz is live, where you can find our climate change documentary, and I will also be posting an update to talk a little bit about our next exam, which I hope to have in about a week or so here. So our next exam is going to cover everything that we've talked about up through climate change. And again, just keep an eye out on your email for your email. I will send out updates as I have them. Thank you all for watching, and I hope you are all doing well. Again, please reach out to me any questions, concerns you might have. I'm here to help, so please reach out if you have any questions. Thank you all. Talk to you soon.